So normally I find when you're doing it, it's not a bad idea to go kind of backwards. Start with that stuff. The stuff we got into last time on the back of the practice test. It's got the stuff from section 10.3. So we're going to start there. Yeah.
So 64 cube root.
Cube root is 64.
Now I know the answer, but I was doing some factoring on my own, and I ended up with 3 sets of 2s. 3 sets of 2 tubes. That's my factor.
Sure, okay. I love it. So if you got 3 sets of 2 twos, right?
That's 4 times 2 times 4.
3 sets of 2 twos. So what comes out is 1 set of 2 times 2, which is 4. What do you have 3 of? 3 2 times 2s. So what's the cube root of that? Then it's equal to 2 times 2.
Because you're going to break it.
You break it into thirds, and you take one of them. So I really want this to make sense. It's not, I got to be careful the way I say this. It's not that it comes out, it's that this is 4, right? Because if I have a 4 just sitting there, how many 4s do I got? 1. And if I raise it to the 3rd power, how many 4s do I suddenly have? 3. So raising something to a power makes more of that thing, right? There was 1 4, now there's 3. So cube rooting something is the opposite. There's 3 4s, it makes it become 1. It just does the opposite of what a cube does. So it's not that a 4 comes out, it's that the cube root of 64 is 4. And the right way to think of it is because it takes 3 4s to multiply to be 64. That's the question that this asks. We got to know what the question is for a symbol. So let's try some more. Here we go. I'll let you guys kind of continue to wake up. So what have I had this year? What you got, Jeff? I don't know, Jeff. Well, let's start off nice. So the first question is, can you do the square root of 18 directly, like you can do the square root of 9? Is 3? Is 3? It's great. The square root of 18, gross. So what do you look for then? If you can discount it as being just an immediate problem, you can't just do it.
Something you can.
Yeah, and I kind of gave it away just now.
16.
Not that adds to be 18. It's got to be based on multiplication, right?
16. 4.
No. 16 is not a part of 18. It ain't. Remember, roots are based on like exponents. They're the opposite of exponents. So they're based on multiplication.
Yeah,
so
wouldn't it be 4 remainder 2? Or remember the remainder of the square root of 2?
I'm not sure what you mean.
Because 4 times 4 is 16, the remainder of the square root of 2.
No, because it's not. It's got to be based on multiplication. That's addition. That's adding 2 to 16. So I know 18 is 16 plus 2, but it needs to break this up in terms of multiplication. What times itself is 18 that I can do the square root of? Not what times itself, but what times something else? What's in 18 that I can take the square root
2
of?
times 9.
Yes, 9 is in 18. 9 is definitely in 18. So I can rewrite. Is everybody with me? You got to break it up using multiplication. You got to, because roots are not division. They're not the same thing as that. They're on the same level as exponents. So what are exponents based on? Multiplication. So what are roots trying to undo? Repeated multiplication. So what are you trying to break them up as? Multiples, right? Factors, multiplication. That's what it can undo. So I can rewrite the square root of 18. I can rewrite it as the square root of 9 times 2, which is the square root of 9 times the square root of 2. Let me stop there for a second. Yes, ma'am.
Can't you just like factor the 9 and put 3 times 3 in?
That's the second method. I'm always going to do this method first because this is just the slightly better method. It is. It's not just because I like it better. It's because there's no question about where things are coming from. Is everybody cool that the square root of 18 is the square root of 9 times the square root of 2? Is that cool by itself?
Yeah.
I like it. It's also the square root of 6 times the square root of 3. Who cares? I can't do the square root of 6 or the square root of 3, so I wouldn't break it up like that. What is the square root of 9? Square root of 9 is 3. What's the square root of 2?
Times the square root of 2.
I don't know what the hell it is. I'm just going to leave it there. So I do prefer this method. If you don't like this method, you don't have to use this method, but there's no question. Where did the 3 come from? Well, because it's the square root of 9. That's where the 3 came from. There's no ambiguity about where to put stuff. So the other method's nice, but you just got to be really careful about why you're putting stuff where. So let's do this again the other way. So I can say 6 times 3. 2 times 3.
Got 2 3s at 6.
I like it. So square root's always looking for groups of 2 of something. So the mistake I always see, is this. Don't write that down. What's the mistake?
3 outside and
Yeah.
We
I got
know
2 3s. So the square root of these 2 3s is 3, and then the poor little 2 is the leftover. So in a way, what you said earlier is right. There's a right way to say it's the remainder of 2, but it's got to be based on multiplication. There's a factor of 2 left over. It remains inside. All right. Okay. All right. Let me try this a different way here. What is the square root of 4? That is 2.
2.
So if I had an extra 5 in there, well, that poor little 5 is still going to be in there because I can't do shit with it. I mean, so it's so if I said the square root of 20, what I'm trying to do is see what extra shit did they throw in there on top of this poor little square dude that wants to get done. It wants to figure out what it is. So if I see 20, oh shit, they got a extra 5 with this 4. So that extra 5 is going to stay inside. I can't do anything with it. But the square root of 4 is 2. I can do that. So it's like the poor little 4 dude has this extra 5 on top of it, making it look like it's not doable. We're trying to uncover what is doable. I'm sure there are other ways to say all that, but I can't. All right. So let's try another one. What if you had what, Jeff? I don't know, Jeff, man, leave me alone. That's a little too easy. Well, all right, let's do this.
75.
So you could either just start tearing it apart, and I know why people like that way, because you don't really have to, I don't want to say that. Well, you don't really have to think. You don't have to think about what's a square that goes into 75. You just start tearing it apart. And I understand the how you like that, but you got to know your squares. So I'm going to try stuff like, well, obviously 9 doesn't go into it, 4 doesn't go into it. Why am I picking those? Because those are squares. So what does go in is
3.
25.
25.
How many 25s make 75?
3.
So this is the square root of 25 times the square root of 3. This is the extra shit somebody put in there. Square root of 25 is
5.
5. Square root of 3 is?
3.
I don't know.
We don't.
All right, let me do that the other way. I don't mean to come telling you guys. I can't blame you. You're like, well, that way is easier. Guess which way I'm going to do. I'm like, all right, I understand. But at the same time, you got to know you want to reinforce which numbers are squares, which numbers are cubes. You got to know that for factoring anyway. So the other way to do this, method 2.
25 3.
Yeah, 25 times 3, whatever you happen to see. And then this is 5 times 5 times 3. So what do you see 2 of?
5.
2 5s. And then the extra 3 is still inside. The remainder of 3, sort of, remains inside. I love it.
So, the remaining unrootable portion will always be a factor when you factor it.
Definitely. Definitely. It's got to be based on multiplication, so based on factors. Bless you.
It should pop up.
Yeah, because here, real quick, let me say this right now, because this is a mistake that my calculus students make that drive me insane. Let me start to plant the seed a little bit. Some people think that that's 3 plus 2. Do you see where somebody would get 3 plus 2 from? And that's 5. That's beautiful. Well, what's 9 plus 4?
13.
So can you do the square root of 13?
No.
So one way you do this, if you decide to do it incorrectly, is you say, it's 5. So you're telling me the square root of 13 is 5. That's neat, right? So this way is bullshit. Why can't I do that? Because roots are based on multiplication. And what's in there?
Addition.
Holy shit, I can't do that. They don't go together. Is that cool? All right, you're not going to see that kind of thing, but I just want to... That's what we're kind of talking about. It's all based on... If this was square root of 9 times 4...
Yeah.
Now that is 3 times 2, which is 6. Right? Square root of 9 is 3, square root of 4 is 2, because what's 9 times 4?
36.
And what's the square root of 36? Freaking 6. That's just 2 different ways to look at the same problem. That's beautiful. It's based on multiplication. Roots all day long go, that's my job. I can do my job. Here is like, oh shit, you're trying to make me do shit I'm not supposed to do. Yes, sir.
So that isn't 3 with the square root of 2?
Which
Or
one?
The square root of, never mind.
Okay.
So that isn't the square root of 13, or that is the square root?
That is the square. That's the correct. That's the only thing you can do with that. This is incorrect.
So 8 plus 5 or something?
No. It's nothing.
2.
Square root of 13, you can't break it up at all. 13 is prime. Because you got to break it up using multiplication if you want to do something, right?
Let me break it up before you do that.
I like it. Okay, let's do another one. Unless you have suggestions on, do you want to keep doing this for a while, or are you guys?
Keep the cube,
Sure. Stuff you had.
for the math practices, for the division, how did you want us to do that? Is it like, you do it like individually, or can you do it like in
Where am I looking?
Like in a division thingy?
No, none of that's on here.
Oh.
We'll get to that in a minute. Let's keep going with this here. Remind me about that in a second. So if I add this, I think on number 3, maybe? So if I had the cube root of what, Jeff? Jeff, man, I don't know, Jeff. 48, sure. So when you see a cube root, and you want to use method 1, which is the method I slightly prefer, doesn't mean a damn thing. If you don't do method 1, I'm not going to go, well, screw you. It's just a little bit better, but oh well. When you see a cube root, what numbers are you thinking about trying to use? What numbers are cube rootable?
3.
No. No. What numbers are made of 3 numbers multiplied together? What's 2 times 2 times 2? 8. So, what numbers would show up in a difference or sum of cubes problem? 8. The next one would be 27, 3 cubed. The next one would be 64, 4 cubed. The next one would be 125, the cube of 5. The next one would be, script line. You can figure it out, 6 times 6 times 6. You got, those are the numbers. You see cube root, you think 8, 27. You don't think 4, 9. That's square roots. So what goes into 48? That's one of the numbers we just talked about. Does 8 go into 48?
Yes, 8 times 6 is 48.
I'm gonna leave. Yeah, 8 times 6 is 48.
But
All right, let me let that sink in.
I was thinking, you know, so like for the actual like cube right now. Like
Oh, I don't know.
4 times
Yeah,
4 times
what's the
4.
cube root of 48? I don't have a freaking clue.
Yeah, so more.
I don't even know what it's near.
Our brain is bigger than this.
All right, let's find out. Hold on. So this I can break up as the cube root of 8 times the cube root of 6. Is that cool right there? And again, why did I think about 8? Because it's a cube root. And 8 is cube rootable. So what is the cube root of 8? 2, because it takes 3 2s to make 8. And what's the cube root of 6?
Nada.
I don't freaking know, that's why I put it over there. You break it up into a part you can do times a part that you can't. It just makes the number work. So then you do the part you can, and you don't do the part you can't. That makes sense. Almost too much sense. So this extra 6, somebody threw an extra 6 on top of this poor 8 dude. He's like, I'm in here. Oh shit, 8, we'll save you. There you go. Maybe. So if you do this the other way, whatever you can think of, when you see this, you can do 2 times 24, 2 times 12, 2 times 6, 2 times 3. What do you see 3 of?
2.
So what's going to be left inside?
6.
2 times 3.
2 cube root of
6.
6. Same answer, thank God. You better get the same answer. Answers don't depend on which method you use, or else we'd all be living in caves. I love that expression. We'd all be living in caves. Alright, maybe. I guess you guys alright? Okay. Yeah, like, what do you mean, am I alright? 4-8, I'm in math class. Alright, I mean that's the idea. You can't, that's the idea. I don't care what number I throw at you, that's the idea. So if I gave you this, the cube root of, oh, you could do it, Jeff, can you? 135, sure. Oh, don't freak out. Here's what's going to save you. This is nice. This is why the first method's better.
125? Then.
Does 125 go into 135? No. You guys look so, I'm sorry. You guys look so joyful, and then I just crushed that. You're wrong. Alright, so what numbers are you trying to divide that by?
5.
No, why does 5 not make sense? Not the, because it's not cube rootable. The first number that is cube rootable is 8. Does 8 go into that?
No.
No. The next number that's cube rootable is?
Oh. No,
Not
no,
9.
not 9.
9 is not, it doesn't matter. That relates to why the answer is what it is. What's the next cube? Come on now, guys. What's 1 cube?
27.
1. That's, I'm never going to try that. 2 cubed is 8. That didn't work. 3 cubed is 27. Let me try that. 27 times. 27 times 5. 5. All right. And you will have your calculator, so you don't have to do this long division. You just have to know what numbers to try. That's all. And then let the calculator do the actual work.
You know what I did? I touched 5 to buy something.
Sure. That's fine too. There's nothing wrong with. There's really nothing necessarily wrong with divided by 2, no. Divided by 3, no. Divided by 4, no. Divided by 5, yes. And then you just happen to get 27, and then you're there.
Yeah.
If you have no idea what else to try, just start dividing by 2, 3, 4, 5. Because I mean that way will eventually get you what you need. Sure. But it's a little better to have some focused way of thinking about it. Because maybe this would have been 27 times, 39 or something. And you're like, that's going to take you a while to get there, right? So I can break this up as the cube root of 27 times the cube root of 5. Is that cool? I can break that up into that. Is that step cool?
Yeah.
And what is the cube root of 27?
33.
What's the cube root of 5?
We don't.
I don't freaking know. 1 point something. So if you find out how to use your cube root button or something on your calculator, don't get all excited, because if you give me decimal answers on these, you're losing all the points. Does that make sense? Don't say, oh, my calculator told me, oh, that's great. Your calculator passed the class. It goes to 110. At least you're behind. Well, calculator sitting at the desk. Oh, sorry. I don't mean this. I do. I mean to be a little bit mean, but okay. Yes. Oh, sure. Anybody else need a practice test? When you get one, there's two sides. There's 10-3 worksheet we did in class. Oh shit, hold on. We have another one.
Do you have that?
How did I run out? Wait. Here we go. Yay!
Stand for a second.
All right. Oh. So let's see.
Receive that.
Who did I skip over earlier? Stephanie, was it you that was asking something, or I can't remember.
Right now?
That asked something
Oh.
earlier that I said, hold on to that.
Yeah, it was about the division and the math.
Oh yeah.
Because I didn't see that in chapter 7.
There's no. Which one are you looking at, for example?
1E?
Whoa, 1E?
Yeah.
What?
I don't know what I have. Yeah.
2E. Okay.
Oh, 2E. Sorry. We're looking at the wrong.
No, we totally did that. This,
Oh, I didn't see it.
how do you? No. How do you do this?
Flip it.
Yeah.
Flip it.
And then you start cross-reducing.
Oh.
So division is multiplication. It's just
Is it just like that?
you multiply by the reciprocal, right? You divide fractions.
Isn't that the where you do it?
No, guys. If your question is about the division,
Yeah.
but you understand the multiplication,
I used on the multiplication.
then all I'm showing you is the division is multiplication. You just flip that. I'm not saying that this problem is on the same level as that one. I'm saying that division is multiplication. So if you understand how to multiply variable expression, rational expressions, then you know how to divide. You just flip the second dude and then you multiply like you would. And then, of course, what do you do next on part E? You factor, so then you can see what cancels.
Yeah.
Yeah, so you
So I
first
can do
flip
like-
the second dude.
So I can break it up and then...
Yeah, totally. You got to.
Okay.
But it's division, so you got to multiply by the reciprocal of the second dude. That's the very first thing you should do is flip that second dude over.
So I would multiply the 8 times the negative 19.
Yes, exactly. Yes, exactly.
Break it into...
Yeah, you still factor it. You just got to flip the second dude over because it's division. That's all. Bless you.
Thank you.
That's money. 3 in a row is money.
Oh.
I don't know, has anybody ever heard that?
In Spanish, it's whatever. Third one's love, but second one's money.
Oh, 2 sneezes is money, and 3 is love. All right. In America, we equate love with money. Apparently.
Oh, first one was help, money, and help.
Okay.
Couldn't remember this
That's funny. And all the while you're getting a cold.
Exactly.
How does that work? All right, so where do we want to go next? It's up to you guys what we do.
So...
Factoring. Seven, where you have 2 answers, 3 answers, more than one possible answer.
Oh, you mean like number 1 of the practice test, maybe? Or are you going back further to like not sure what you mean.
هذا النمل يرجع أبوه النمل.
Look for it, Nate. Let me know when you find it.
And later, could we do number 6 together here
Yeah, 6, 6.
in practice test?
Sure.
Yeah, thank you.
All right. So let me get Nathan's first. He found, so that is what you're talking about. Okay, because that does happen with number one sometimes. You know, when you simplify the stuff in number one.
Okay.
But basically, it's here's the idea. Sure, I like it. So what if you're working a problem out? You've done some work, blah 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 blah, and you get there. This is huge. Huge. What should you do next, and why?
Get rid of 6x.
Nope.
Because that's actually
Bring equals zero.
factor units each side out.
If that wasn't there, I would just subtract x, divide by -7, be done with it.
Make it zero.
Make it 0 because there's an x piece that I can't put together with the other x pieces, right? There's a power higher than 1 on one of my x pieces that tells me I've got to get it equal to 0. That was the whole idea of section 6.6, the 0 property rule, whatever this book calls it. So you got to subtract x out of 12. So you get x squared minus 7x plus 12 equals 0 because then I can factor to see what makes it 0. So it's because of this. Can I put my x's together?
No.
No. So I need a new way to do this. If that wasn't there, I could put my x's together. So I would, and then I would divide by the coefficient. That's chapter 2. Right? That's solving equations. Now I got this. When this is in an equation, I have to develop a new method, which is get it equal to 0 so I can factor that.
So when you have an equation with an exponent,
You get it equal to 0 and you factor this side. Because then what can you do? How do you factor this?
x negative 3 minus 4. Yeah.
So then x is,
Well, actually, that wouldn't work. Never mind, Luke.
Three.
x is 3 or
4.
x is 4. Right? 3 makes that 0, 4 makes that 0. Yep. Cool. Yep.
And if it were in a fractional equation, if one of those answers made it undefined, you would...
Exactly. If the beginning problem had this in it, blah, 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 you'd have to throw 3 out. If the original problem had this in it, 3 can't be an answer because it makes the original problem undefined. So it's the last thing you do when stuff like number 1 on the practice test, you check your answers to make sure none of them freak the problem out. So if this was what it looked like originally, blah, 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 you'd say that's out, then the only answer is 4.
So just cross the x.
Yep. Show me that it's there. Don't not write that because then I'm worried that you didn't see it, and then just cross it out. Say, nope, can't work. Only that works.
Solution for the equation.
Well, there is a solution.
No.
No. You're answering the question of what solves this. So don't say no solution here because there is a solution. It's just that that one doesn't work. Yeah. Yeah.
If you give me another one that just works great.
All right. You guys want to try that one? Let's do it. It will be. Well, what do I have to do first? So whenever I see a higher power than 1 on an x, it's got to be equal to 0. I've got to get it equal to 0 so that when I get to this step, I can actually give you answers.
So no matter what is going on, if you have anything above the first power, you gotta just combine everything and then
Exactly. You have to. Because if this was a 2, I don't know what the answer is. Because how many things multiply to be 2? An infinite number of things. You guys might not agree with me, like Jeff, I can only think of 2 times 1. Well, I can think of 4 times a half. I can think of 8 times a fourth. I can think of 200 times 1 over 100. There's an infinite number of things that multiply by 2. But how many things multiply by 0? 0 times something. So one of them's got to be 0. There's a known thing when it's equal to 0. I know that one of them have to be 0. That's why I'm able to get answers when it equals 0. So that's why the first thing here is get it equal to 0. So that's 0. Here I get
1 x squared. 9.
Minus 9.
Minus 9.
like you said,
X. minus plus 3.
So the next is
3 or
Here, rear view 3.
yes.
So how come we were able to move the x2 plus 1 over to this x because you're doing both to both sides?
Yeah, I'm doing the same thing to both sides. As long as you do the same thing to both sides, it's legal, except multiply or divide by 0.
What if it was 2x2 equals x2 plus 1? Would you still be able to...
You actually made a problem that'll work nicely. Because, I mean, again, do I see a power higher than 1 on my x?
Yeah.
So then I want to get it equal to 0. Yeah.
So is that 2x to the 4th?
Hell no.
That's 3x.
I don't see any x to the 4th. I see 2x squares minus 1x squared is how many x squares? 1x squared minus 1. And then you can actually factor that. It's nice. You made a nice problem. Yeah.
So even though the addition is there, you're allowed to
What addition?
remove
Where?
it because there's subtraction involved.
Yeah, I'm doing the opposite of it to cancel it out. Yeah, that's all.
You're not multiplying or dividing. That's why the x plus anything
Can be moved over. I like it. I like it. If it was a minus 1, I would have added it. Whatever I have to do to make it cancel.
But because you can't factor something like that or do any of the other stuff because of the